One.
Good morning, good afternoon, good evening, whenever you're watching this video. This is Math with Mr. Samuels and Ms. Brunel. Just like usual, make sure you have your notes before you start this video. Let's go ahead and get rolling. Okay, so today we're talking about theoretical probability versus experimental probability. As you all can see, I've already wrote in the definitions, but we will talk about them. Okay, but before we talk about anything, I want to look at portions of each word before we start. Okay, so if you look at theoretical probability, okay, we have this word "theor" in the front. Okay, that reminds me of theory. So when we're talking about theoretical probability, we're talking about what is supposed to happen in theory. Okay, experimental probability. If you look at that, the beginning of that word, we have exper, which clearly sounds like experiment. So, as you probably guessed, this type of probability is going to deal with an experiment. So, let's dive into the actual definitions. Theoretical probability is what should happen in an experiment. So, for example, what I mean by what should happen is, in theory, what exactly should happen. So, let me give you a perfect example. If you toss a quarter or some type of coin 100 times, then you would expect for it to land on heads 50 times and expect on it to land on tails 50 times. Because what? Well, it only has two sides, and in theory, it should land on both of them equal amount of times. But when we look at experimental probability is what actually happens after an experiment of many trials. So let me give you an example there. Let's say we do flip a coin 100 times and it lands on heads 70 times and it lands on tails 30 times. Okay. Notice how it's different from the theoretical probability. Most of the time, experimental probability is different from theoretical probability, because when you actually do it, you don't always get the same results as what's expected. Okay, so let's look at a closer example. Okay, we're going to look at everybody knows the game of rock paper scissors. So we're going to look at the theoretical probability of rock paper scissors. Okay, so if we have rock versus rock, we know that that will be a draw. If we have paper versus rock, okay, then clearly player A would win. If we have scissors versus rock, then player B would win. Okay, so you all going to fill out the rest of this chart. Okay, rock versus paper, then player B would win. Paper versus paper, that would be a draw. Scissors versus paper, then clearly scissors would win. Rock versus scissors, player A would win, and scissors versus paper, then player B would win. Okay, so now what we're going to do is look at those different probabilities. So what is the probability of player A winning? Okay, so if we look at our chart, player A won 1, 2, 3 times. So that's 3 out of 9. You guys know that anytime we're dealing with fractions, we have to reduce. So the probability of player A winning is 1/3. If we look at the probability of player B, then we have a similar type of probability. If we look at the chart, player B won 3 times, and that is 3 out of 9, which is simplified down to 1/3. Okay, and last but certainly not least, what is the probability of a tie? That is 3/9, okay, which is 1/3. Okay, now what I want you to do is I want you to hold off on doing this experimental probability. We are going to do this in class. And after we do it in class, we are going to compare the results of the theoretical probability and experimental probability. So just hold off on this half of the notes over here for now. We will do that in class when you guys come back tomorrow. Okay. So let's move on down to some examples. Okay. A couple of examples. I'm going to do one example, and then you all are going to be responsible for the bottom two examples. Okay. So this one and the bottom one, you all are going to do those. Okay, you're going to answer for number 10, you're going to answer questions A and B. And for number 11, you're going to answer questions A and B. And for number 12, you're also going to answer questions A and B. So you're going to be responsible for those last three. But I went ahead and did the top one for you. Okay, so let's look at it. It says the table below shows the results of rolling a standard die 50 times. Okay, so the first question that they ask us is, what is the theoretical probability of rolling a 4? Well, if we're talking about a die, okay, a die has 6 sides. One of those sides is 1, one of those sides is 2, 3, 4, 5, 6. Okay, now if they ask us what's the probability of rolling a 4, then 4 is one of those sides out of a total of 6 sides. So that probability, that theoretical probability, is just simply going to be 1/6. Okay, so now let's answer question B. What is the experimental probability of rolling a 4? Compare this to the theoretical probability. If we look at this table, according to the frequency table, 4 was landed on when we rolled the dice. 4 was only landed on 5 times. Okay, 4 was only landed on 5 times. Now the total number of trials when they did this experiment was 50. Okay, 10 plus 4 is 14. 14 plus 9 is 23. 23 plus 5 is 28. 28 plus 12 is going to be 40. And 40 plus 10 is going to be 50. So that experimental probability for landing on 4, according to this table, was 5 out of 50, which if we reduce it, reduces down to 1/10. Now, if we compare that to the original theoretical probability, clearly we see, or we should see, that what actually happened in the experiment ended up being lower than what was expected to happen. Okay? So this is just a perfect example of you seeing that it doesn't always guarantee that whatever the theoretical probability is, we get the experimental probability. Okay, so like I said, you guys have to go ahead and complete problems 10, 11, and 12. Okay, make sure you have them ready. One more quick reminder, please hold off on questions 4, 5, 6, 7, and 8. We're going to do the experiment in class, and then we're going to compare those two results. Okay, this is Math with Mr. Samuels and Ms. Brunel. Thank you. Make sure you do your homework. Have a good evening.